We want the area inside this curve and outside this curve. So we need to find out where these curves intersect each other. So we'll set them equal to each other. 3 cosine theta equals 1 plus cosine of theta. So if we subtract the cosine theta over, we have 2 cosine theta equals 1, or cosine theta equals 1/2. So this happens when theta is negative pi over 3, or positive pi over 3, or 5 pi over 3, etc., etc. So we need to choose the correct interval here. I'm going to draw a picture to illustrate, and we'll see from that, but then also show you how to determine it algebraically. So we should be able to graph these. R equals 3 cosine theta, that's a circle. That comes around there, it comes out to 3. R equals 1 plus cosine theta, it comes out to 2. And comes around and then does something like that. Okay, so it's inside the circle but outside that cardioid. So we're looking at this region here. So it's pretty clear we're going from negative pi over 3 to positive pi over 3. However, if you're not sure, all you need to do is you look at intervals and say, well, if we choose something between those two, say 0, if you plug it into this function, you get r equals 3. If you plug it into this function, you get r equals 2. Which means this function is bigger, this one's smaller, and that makes sense because we want it inside the bigger one and outside the smaller one. And so that would tell us, oh, those are the bounds that we're going to use. So we go from negative pi over 3 to pi over 3. We have 1/2. And then we do the bigger function squared minus the smaller function squared. So the bigger function, that's 3 cosine theta. We have that squared minus the smaller function squared, 1 plus cosine theta squared. All right, so let's go ahead and square those. We get 9 cosine squared theta minus 1 minus 2 cosine theta minus cosine squared theta. So the cosine squareds, those will combine, and we will have, from negative pi over 3 to pi over 3, 8 cosine squared theta minus 2 cosine theta minus 1 to integrate. Now we're going to use the half-angle identity on this cosine squared. Remember that cosine squared is 1/2 1 plus cosine of 2 theta. So multiplying that by 8, so that gives us a 4 actually, and then times that. So it's 4 plus 4 cosine of 2 theta. And then we have minus 2 cosine of theta and minus 1. From negative pi over 3 to pi over 3. All right, let's go ahead and integrate. So first of all, we have 4 minus 1, that's 3. So integrate that, you get 3 theta. And then here we've got, it's going to be a 2 sine of 2 theta. And then here we're going to have minus 2 sine of theta. And we're evaluating from negative pi over 3 to pi over 3. So let's go ahead and plug in pi over 3. We just get pi here plus 2 times the sine of 2 pi over 3 is square root of 3 over 2. And then minus 2 times the sine of pi over 3 is also square root of 3 over 2. And then we subtract. Now plugging in negative pi over 3, we get negative pi plus 2 times the sine of negative 2 pi over 3 is negative square root of 3 over 2. Then minus 2, and sine of negative pi over 3 is negative square root of 3 over 2. And that's what we're subtracting. So now to simplify, we have pi plus pi, that's 2 pi. Here we have, let's simplify, this is square root of 3. And this is minus the square root of 3, so those actually cancel each other out. That's nice. Over here we've got negative root 3, and that's plus root 3, so those also cancel each other out. That's nice. And so that's all we have. We are now left with 1/2 times 2 pi, which is pi, and that's going to be the area.